All right, so the next kind of rational application problems we're going to talk about is inverse variation. In Algebra 1, you learn something called direct variation, which corresponds to linear equations. In Algebra 2, you're learning about inverse variation, which corresponds to rational functions. And so something varies directly if the magnitude of one variable causes the increase in the magnitude of the other. And for inverse variation, it's the opposite. As one variable increases, the other gets smaller and smaller and smaller as it goes to zero. And so we're going to look at some examples of inverse and direct variation. So for number 1, it says the time to complete a job varies blank with the number of workers working. Okay, and so the more people working, the less time it would take to do the job. And so this would be inversely. Okay, as the number of workers increases, the time decreases. The time it takes to complete a specific trip varies blank with the speed of travel. Well, as you increase your speed, it's going to decrease the time it takes to get there. And so this would be another inverse variation. As one increases, the other decreases. The cost of gas on a trip varies blank with the length of the trip. Well, as you increase the length of the trip, you're going to increase the cost of gas because you need more gas for that. And so this would be directly. Directly. The number of people invited to dinner varies blank with the amount of space each guest has at the table. Well, the amount of space is going to decrease as you increase the number of people. And so this would be inverse. Inversely. The number of people invited to dinner varies blank with the number of pieces of silverware used. This would be directly. More people means more silverware used. Okay, and so as a review of direct variation, the variable x and y vary directly for a constant k gives us the equation y equals kx. It's linear. And k is called the constant of variation. And it's basically your slope since this is linear. Okay, so as you're always going to want to set up this equation, and they're going to give you enough information to find k, and then they're going to ask you to find a different value. Okay, so here on number 6, it says y varies directly with x. As soon as I see that, I write y equals kx. Okay, and then y is 15 when x is 3. Y is 15. We don't know k when x is 3. This is them giving you enough information to figure out what k is. I would then divide by 3, and I would get k equals 5. And so my equation, y equals kx, is y equals 5x. And so now it's asking me to find y when x is negative 2. And so now I've got this beautiful equation where I can solve for y. And so it would be negative 10. And so the answer to this question would be y equals negative 10. Okay, for number 7, it says y varies directly with x, so we can immediately write y equals k times x. And y is negative 24 when x is 4. Be careful to replace the correct variables. So that was them giving us enough information to find k. which is -6. That's our constant of variation. And so now our equation is y equals -6x. Okay, so this is still direct variation, even though it's a negative slope. The magnitude is what we're focusing on. As we increase the magnitude of x, the magnitude of y would increase. Magnitude measures distance from 0. And so it's getting, like for debt, your debt is getting larger and larger and larger. All right, and then find x. So this time we're finding x. We don't know this guy, but we know y is -30. So make sure you replace the correct variable. And now we can solve for what x is by dividing by -6. And so x equals +5. Okay, another way that you could solve these is by setting up a proportion. And so when you do that, you do y1 over x1 equals y2 over x2. Because the idea here is k, our slope, or our constant of variation, is whatever y divided by x is. And so since it's constant, we know no matter what y into x we're given, if we take y divided by x, we're going to get the same number regardless. And so, for example, in number 7, when they say y is -24 when x is 4, find x when y is -30. And so then you may have learned to cross multiply this. 4 times -30. That cross multiplication is just a shortcut for getting a common denominator. And so 4 times -30 is -120 equals -24x. Divide both by -24. And 120 is 5, just like we found before. And so that kind of bypasses getting this equation. You just have to be careful because this method is going to be different when we're dealing with inverse variation. And when you use this purple method, you also don't figure out what k actually equals. And so if the problem is asking you for k or this equation, you have to set it up this way. Okay, so that's direct variation. For inverse variation, we have a rational equation. So if x and y vary inversely, our equation, what color did I use? Red. Would be, instead of y equals k times x, is y equals k divided by x. That's why it says x can't be 0. We now have a domain restriction because this is rational instead of linear. Okay, and so an example is intensity of sound varies inversely with distance away. The further away, the intensity of the sound decreases. Okay, and so when we solve these problems, we can follow the exact same steps where we find k and then use that equation to find the missing information. So here it says y varies inversely with x. As soon as you see that, go ahead and write your equation, y equals k divided by x. And then it says y equals -3 when x is 4. That's them giving you enough information to find k. I would multiply both sides by 4 to get k equals -12. And so now I can write my complete equation. And if all they wanted was the equation, I'm done. There's the equation. And that is part of the standard. It says you can write an equation. And so if they ask for the equation, you're done. Okay, this problem says find the constant of variation, which we did. It's -12, and the equation relating y and x. So there's the constant of variation, and there's my equation. Then find y when x is 6. Okay, that's our third part. And so find y when x is 6. just plug and chug, you get y equals -2. And so 3 things they asked us to find: the constant of variation, the equation, and then the value. Okay, on number 9, y varies inversely. So you are going to be going back and forth between direct and inverse. And so make sure you write the correct equation. Y varies inversely with x. Y is 2 when x is 7. Multiply both sides by 7 and you get k equals 14. And it says find y when x is 10. So my equation now, we're basically just filling in k. And then we're plugging in 10 for the x. And so that gives us 1.4. Okay, so the y value would be 1.4. And so the equivalent to setting up this proportion that I did over here is, instead of this idea, y1 over x1 equals y2 over x2, this time the product is the same. If I were to solve for k, I would get x times y. I would multiply both sides by y and get the product as constant rather than this rate or this ratio. And so here, instead of having this y1 over x1 equals y2 over x2, I'm going to have x1 times y1 as constant. And so you would set up this equation to bypass finding the k value. And so let's see, y is 2 when x is 7. Find y when x is 10. Filling those in, I get 14 equals 10y2. Divide both sides by 10. And you get y2 equals 1.4, just like we got here. Okay, so for direct variation, you set the fraction y over x equals y over x. For inverse, you set the products equal to each other. And for anybody in physics, you actually do this for MV. It's kind of an application of this. So both methods work. You can use this purple method, or you can use this blue method over here to solve for any missing variables. The problem is, if they're asking for the equation, make sure you actually find that equation. Okay, so on the back, it says for each table, determine if it models direct, inverse, or neither. Okay, and so that's where this idea comes into play. For direct variation, we know the ratio y over x should be constant. Y over x should equal some constant number. And that comes from the equation y equals k times x. If you divide both sides by x, that's where we get this. So the ratio is constant. Y over x is constant. For inverse, the product, x times y, is constant. And that comes from the fact that our equation is y equals k divided by x. So if I multiplied both sides by x, that would give me the product being constant. Okay, so when we have a table, that's what we're looking for. And so for the first table, notice I go, as x increases, the value of y is getting smaller and smaller and smaller, closer to 0. So I'm thinking it's probably inverse. And so I'm going to check. If I multiply x times y, 1 times 4 is 4. If I multiply x times y here, 2 times 2 is 4. I'm going to skip that because it's a decimal. X times y would also give me 4, since 4 times 1 is 4. And this is the same as 4/3 if I were to multiply them. they would also be 4. And so because x times y is always 4, regardless of the value, I know that this is an inverse variation. And if you divide both sides by x, it gives you the equation y equals 4 divided by x. 4 is your constant of variation here. Okay, for the second table, notice as the magnitude of x is increasing, so is the magnitude of y. So I'm thinking it's probably direct. And if we check, y divided by x in this case, 4 divided by 1 is 4. Here, if we divide them, 8 divided by 2 is also 4. 12 divided by 3 would be 4. And then, so in each case, if we divide y by x, it's always 4. And so because that ratio is constant, we know it's a direct variation. Since y over x equals 4, if you were to multiply both sides by x, you would get your direct variation equation, y equals 4x. Okay, and so that's just dealing with y's and x. These do, have applications to real world problems. And so my advice for dealing with real world problems is choose meaningful variables. Don't use x and y. For example, if we're dealing with illumination and distance, use I and D. Okay, so for number 11, it says the illumination I varies inversely with the square of the distance D. So the square of the distance would be D squared. And so now it's going to give us enough information to find K. 1 meter away, that's when D equals 1, from a certain light, the illumination is 750. So 750 for the illumination, and D squared would be 1 squared, which is just 1. Okay, so in this case, K equals 750, and my equation would be I equals 750 divided by D squared. Okay, write an equation that relates I and D. So if that's all they wanted, I'm done. Then find the illumination at a distance of 2 meters away. So we would plug in 2 for the distance. Make sure you replace the right variables. And we get 750 divided by 4, which is 187.5. And that's illumination measured. I don't know what that's measured in. 750 luxes. Okay, for number 12, it says the frequency of a pitch varies inversely with diameter. So there's my equation. If the diameter is 5, the pitch is 500. We can solve for K by multiplying both sides by 5. And I get K equals 2500. And so my equation looks like this. If we're relating frequency to the distance, there it is. What is the frequency of the pitch? 15 millimeters away. So I would replace D with 15. And 2500 divided by 15 is 166.6 repeating. And that is measuring hertz. The number of songs on an iPod varies inversely with the average size of the song. An iPod stores 2,500 songs, so they're using N for songs. So N varies inversely with the size of the song. So let's use S. And so when there's 2,500 songs, the average size of the song is 4 megabytes. If the average size of the song is 5 megabytes, how many songs fit? Okay, and so we have to multiply by 4 to find K. Which is 10,000. And so my equation to relate the two is 10,000 divided by S. There's my equation. And then we need to replace S with the 5, which already looks like a 5. And so in that case, we get N equals 2,000. So 2,000 songs fit if the average size is 5. Okay, last one. A roof is covered by hail that is 0.5 inches deep and weighs 1,800 pounds. If the hail's weight, W, varies directly with the depth, D. So this time we're setting up that linear equation, not a rational equation because of this word directly. Okay, write an equation that relates D and W. Okay, and something I haven't mentioned yet is the script. Okay, whatever is listed first is your Y. Okay, so roof covered by hail, so weight varies directly with depth. Weight comes first, so that's your Y. Whatever is doing the varying is your Y. And so let me get a different color, and we're going to write this at the top of your paper. So, well, let's write it at the bottom. Y varies with X. Whatever's listed first is your Y. If it said, the other thing they might say is blank and blank vary. If they just say blank and blank, this is X, this is Y. Okay, so X would be first, Y would be second. But if they say blank varies with blank, the first one's your Y. So watch out for those two scripts. All right, so weight varies directly with depth. Write an equation. And so we know that the depth is 0.5. The weight is 1,800. And so to find K, we have to divide by 0.5. And I believe that's 3,600. It is. So K is 3,600. That's our constant of variation. And so our equation, our linear direct variation equation, looks like this. And then it says predict the weight for 1.75 inches. So replace D with 1.75. And we get 6,300 pounds. And that's inverse and direct variation. Be able to do both and to read the scripts to determine which equation to use.